Today our topic is probability distribution function. Definition of the probability distribution function. The probability distribution function capital PDF defines the probability capital P capital P of capital X less than or equal to small x of the event capital X less than or equal to small x for all values of the variables capital X up to the value of small x. It is denoted by fx of x is equal to P of capital X small less than or equal to small x. X is the real number. The integer ranges from minus infinity to infinity. Explanation of the PDF. Consider an experiment tossing a three pair coins. If x is a discrete random variable of the event showing the number of heads, then the discrete random variables has elements x1. x1 is equal to 0 for the event no coin shows heads. x2 is equal to 1 for the event one coin shows heads. Where x3 is equal to 2 for the event two coin shows heads. Where x4 is equal to 3 for the event all coin shows heads. Therefore, capital X is equal to 0, 1, 2, 3 the events. We know the favorable outcomes of x1 is H. Heads, 3 heads is equal to 1. The probability of the getting x1 is we are taking an event x1, getting a 3 heads is equal to 1 in one time. The probability of getting event x1 is p of x1 equals to 1 by 8. Since the possible outcomes are for each coin toss, there are two outputs, heads or tails. In that, there are three. We are tossing three coins. That equals to 2 power 3 is equal to. There are eight outputs for tossing a three pair coin one time. So the probability of getting heads in three coins is equal to 1 by 8. In the case this similarly, the probability of getting event x2 is equal to p of x2 that equals to 3 by 8. Since the number of favorable outcomes for event x2 is equal to in this there are three outcomes for tossing a three pair coins. The first one gets tails and the other two gets heads. And the first one gets heads and the second one gets tails and the last one gets heads and the first and second get heads and the last one get tails. There are three outcomes and case 3. So probability of getting event x3 is equal to 3 by 8. This is also getting 3 by 8. In the case 4, the probability of getting event x4, getting a 3 tails from a tossing a 3 coins that equals to 1 by 8. Since the favorable outcomes of event x4 here, uh, getting a 3 tosses in one time is equal to 1. The distribution function f of x is equal to p of capital X less than or equal to x. In this, we are taking three events x1, x2, and x3. So we are considering the distribution function as f of x is of x1 event 1 is equal to p of capital X less than or equal to event 1 that equals to 1 by 8. Since there are one output, total number of outputs 8, the favorable outcome is 1 and probability of getting event x2 is equal to p of capital X less than or equal to small x2 that equals to sum of two probabilities, sum of two events, x1 and x2. We are summing the two events 1 by 8 plus 3 by 8 that equals to 4 by 8. And event x3, probability of event x3 is equal to sum of all three events, event 1, event 2, and event 3. That equals to 1 by 8 plus 3 by 8 plus 3 by 8. So total is equal to 7 by 8. And the probability of getting event x4, sum of all events, summing of all events, we are getting one value. So getting the distribution function values, we are considering the random variable x, getting the events, event x1 as 0, event x2 as 1, event x3 as 2, event x4 as 3. And the probability of event x1 is equal to 1 by 8, probability of event x2 is equal to 3 by 8, probability of getting event x3 is equal to 3 by 8, and probability of getting event x4 is equal to 1. And this is the distribution function we calculated, probability of distribution function of the event x1 1 by 8 and the distribution function of event x2 adding the event x1 and x2 that equals to 4 by 8 and getting the event x3 adding the two events to the third event getting 7 by 8 and the last getting event x4 adding the three events event 1 event 2 and event 3 and the event 4 we get the value of 1 and this is the graph This is the graphical representation of distribution function. Here we taking event 1 as 0 and the value of event 1 is equal to 1 by 8. Since the number of outcomes is 8 and the favorable outcomes is 1, we are taking this as effects of small x. So in the x2 event we get the value of 3 by 8. In the x3 event x3 we get the distribution function value as 7 by 8, and the event x4 we got the value of event 1, the value 1. So this is a discrete staircase function of the distribution function of x. We are considering an example for probability distribution function. This is a question. An experiment has a random variable of x, has elements x is equal to 1, 2, 3, 4, 5, 6, with probability of P of x1, event 1 gets 2 by 36, and event 2 gets 8 by 36, and event 3 gets 12 by 36, and event 4 gets 7 by 36, and event 5 gets 5 by 36, and last event gets 2 by 36. Draw the distribution function of x. This is the solution given considering given values. Variable random variable x is equal to 1, 2, 3, 4, 5, 6. This is the probabilities of all random variables 1 to 6. The distribution function of x is given as f of x is equal to probability of getting event x1 that equals to 2 by 36. We are considering these as cases. The case 2 is event x2. Probability of getting event x2 is equal to adding the first event and second event. We got the value of 10 by 36. And the case 3, probability of getting event x3 is equal to adding the two events to the third event, 10 by 36 plus 12 by 36. So, where that equals to 22 by 36. And the case 4, probability of getting event x4 is equal to adding the four events where the three events get out the value of 22 by 36 and the fourth event is 7 by 36. So the value is 29 by 36. And the case 5 getting probability of event x5, summing the four, adding the four events to the fifth event. We got the fourth event 29 by 36 and adding to the fifth event 5 by 36. The total is 36 by 34 by 36. And the last event, x6, probability of getting x6 is equal to adding the all events, event 1 to event 6, that equals to 36 by 36. So the value is equal to 1. We took random variable x and the events are 1 to 6. We know the probability of the events 1 to 6, where event 1 got 2 by 36, event 2 got 8 by 36, event 3 got 12 by 36, event 4 got 7 by 36, and event 5 got 5 by 36, and the last event 6 got 2 by 36. So the distribution function of the events we calculated. Event 1 got 2 by 36, event 2 got 10 by 36, event 3 got 22 by 36, where event 4 got 29 by 36, and event 5 got 34 by 36, and the last event x6 got 1 as as the distribution function. This is the tabular representation of PDF for the events 1 to 6 and the probability and their probabilities. This is the tabular representation of the events random variable x. We are considering 0 to 6 as the x value, and this is their probabilities 2 by 36, 10 by 36, 22 by 36, 29 by 36, 34 by 36, and 1. Here we noticing that there are staircase values where they are increasing to 1 0 to 2 by 36 to 1 value. There is an each step adding to each event, and they are creating a staircase function. This is the graphical representation of the PDF or f of x. So